A number whose decimal expansion is a terminating or non-terminating recurring is a rational number. And if any decimal number is in the form of a repeating or recurring form or terminating form, we can write P by Q form. Then what is a irrational number? Then what is the value of root 2? So what about the famous for irrational numbers? So root 2 is a famous for irrational number. Irrational numbers. What is the decimal expansion of irrational numbers? Non-terminating, non-repeating, non-repeating decimals are irrational numbers. Let us take a root 2 as an example. Root 2 is 1.4142 13562 13562 730950 488 01688 7242 09096 up to 7. Look at this number. Any of the number pattern is repeating here? No. None of the pattern of the digits is repeating. So it is a continuous. It is continuous. There is no end. So the mathematicians have developed the various techniques to produce more and more digits in the decimal expansion for irrational numbers. In the Vedic period, 800 BC to 500 BC. So which is, you can find root 2, approximation of root 2 as follows. Root 2 equal to 1 plus 1 by 3 plus 1 by 4 into 1 by 3 minus 1 by 34. This is minus 1 by 34. 1 by 34 into 1 by 4 into 1 by 3 equal to this is the approximate value 1.4142156. So using this method we can find the approximate value of root 2. Look here, find an irrational numbers between 1 by 7 and 2 by 7. We have an example problem. So to find the irrational numbers, an irrational number between 1 by 7 and 2 by 7, we saw that 1 by 7 is 0.142857, which we solved just before this. So you can easily calculate 2 by 7. So 2 by 7, after dividing 2 by 7, we get 0.285714 bar. You already know bar represent the repetition of a set of decimal places, set of the digits after the decimal points. To find an irrational numbers between 1 by 7 and 2 by 7, we find the number which is non-terminating, non-recurring, lying between them. Non-terminating, non-recurring means irrational number. Of course, you can find infinitely many such numbers. An example of such numbers is 0.150, 1500, 15000, 1540 up to so on. So now get into exercise 1.3. Write the following in decimal form and say what kind of decimal expansion each has. The first one, 36 by 100. What kind of decimal expansion of 36 by 100? This is exercise 1.3 in the first chapter, class 9. So write the following in decimal form and say what kind of decimal expansion each has. So first one, 36 by 100. Solution, 36 by 100 can be written as 36 by 100 equal to, we have divided by 100. If we divide the number by 100, we get 0.36. So this is the decimal form of the 36 by 100 is 0.36. And what kind of decimal expansion is this? This is a terminating expansion, terminating decimal. The second one, so look here, to know this we have to divide 1 by 11, take a decimal point, then we can write 0. Again 10 is smaller than 11, so write one more 0. So 11 nines are 99, so 100 minus 9 is a 1. So because of decimal point we can write 0, then take 0, write one more 0, then again 9, 99, again 1. So there is repeating 1 as a reminder, so it cannot end anywhere. So this is 1 by, the solution is 1 by 11 equal to 0.0909 up to 7. It can repeat. So it is a non-terminating repeating. This is non-terminating and repeating or recurring. Non-terminating repeating decimal, or we can use instead of repeating, recurring. Now look at the third one, 4 1 by 8. So first change into mixed fraction into improper fraction. 4 8s are 32, 32 plus 1, 33 by 8. Then divide 33 by 8. 8 4s are 32, remainder 1, and then take a decimal point. 8 1s are 8, remainder 2, and take 0. 8 8 2 16, 20 minus 6 is 4, then take a 0. 8 5s are 40. This is the remainder 0. So it is 33 by 8 equal to 4.125. We got remainder 0. So it is a terminating decimal. It is terminating decimal. This is a rough work, division. Next, 3 by 13. Solution 3 by 13. So we have to divide 3 by 13. 0. Take 0 at quotient. We can write 0. 13 2s are 26. The closest multiple to 30 is 26, which is 30 minus 26 is 4. And then take a 0 because of decimal point. And 13 3s are 39. 1 is a remainder. Take a 0. So even though taking 0, 10 is a smaller. So write one more 0. And here. And 13 7s are 98. So 98, remainder 2. So write a 0 because of decimal. We can write 0. Then 13 1s are 13, remainder 7. Can write 0. 13 5s are 65. Minus remainder 5. And write 0. Then 13 3s are 39. 13 4s are 52 is greater than. So 13 3s are 39. Then 50 minus 39 is 11. So write 0. It becomes 110. 13 8s are 104. So 110 it is 6. Then write 0. 13 4s are 52. Remainder 8. So again 8. 13. What is the closest multiple in 13 table to 80? In 13 table, closest multiple of 13 is 13 6 are 78. There is no place. That's what I have written here. So remainder 2. Again 2. Look here. 2 is already, we got a remainder as a 2. So we'll get the same pattern. After some digits, we'll get the same pattern. So 13 1s are 13. Remainder 7. Then write 0. 13 5s are 65. Remainder 5. So after these many decimal places, the pattern is going to be a repeat. 1 5 3 8 4 6 is going to be repeat. So these are non-repeating decimals. Up to 7. 2307 won't be repeat. So this is the non-terminating decimal. It equal to 0.230715,384 bar 6 bar, because this set of numbers is going to be repeat. So non-terminating. Repeating. Then 2 by 11 is, take a decimal point at the quotient to write 0. 11 1s are 11. 20 minus 11 is 9. Then we can write 0 because of this decimal point. Since we have a decimal point, so we can write 0. 11 8s are 88. Remainder 2. So again, since we have a decimal point, we can write 0. 11 1s are 11. 9. Oh, remainder is repeating. So it is going to be repeat the same pattern of the numbers, which is 88, remainder 2. So what is going to be repeat? 1 9 2. 9 2 is repeating. in the quotient, it is repeating 2 by 11. Solution 2 by 11 equal to 0.1818 up to 7. So this is also non-terminating repeating decimal. Non-terminating repeating decimal. Now look at this. 329 by 400. Solution. So 400, 329. So 329 is smaller than that. So take a decimal point. Now 3200. In 4 table, closest multiple to 3200 is 4 8s are 32. Let's try with 8 zeros are 0. 8 zeros are 0. 4 8s are 32. Remainder 90. So then take 0, 900. 400 2s, 800. 900 minus 800 is 100. Then we can write one more 0. Since we have decimal point, so we can write 0 at the denominator. If it is smaller than divisor, then we can write 0. 400 2s again, 800. Then 1000 minus 800 is 200. So again we can take 0. Then 400 5s, 500, 500, 5 4s are 20. Remainder 0. So if we have a remainder 0, it will be a terminating decimal. What type of decimal is this? Terminating decimal. So the decimal form of 329 by 400 equal to 0.8225. Thank you for watching.